Welcome back, geometry students. For today's notes, you will need in-class 47, but it is the day 2 of the notes. Yesterday we started working on Pythagorean Theorem, and today we're going to continue and deal with some scenarios that use the same formula but have a little bit of a difference in terms of the simplifying part of the problem. But we're building on what we did yesterday, which is why your notes today begin with a warm-up problem. This is review of what we already know, so if you'd like to pause the video, try it on your own, and then come back and check your answer, that's totally fine. Otherwise, remember that we are going to be using c squared equals a squared plus b squared anytime we're dealing with a triangle that has a right angle and we have labels on all three sides. We're going to travel across from that right angle to identify the c. And so for this equation, it's going to end up looking like 16 squared equals, either of these can be a, so I'm going to choose x squared plus 8 squared. Next up, we're going to simplify our exponents. 16 squared is 256, x squared is x squared, and 8 squared is 64. For this equation, we need to subtract, so 256 minus 64 gives us 192 equal to x squared. And then remember, to get rid of that exponent, we're going to square root both sides. And that brings us to the point where root 192 equals x. But as we saw yesterday, sometimes square roots can be simplified. So if we head to our calculator and we try to square root 192, it's not a perfect square, so that gives us a decimal answer, which means we need to switch over to one of our methods, either factor trees, factor tables, perfect square method, whatever you choose, to figure out if we can simplify root 192 at all. So if we go about this using a factor table, we've already shown that 192 is not going to work, so let's go ahead and try to divide that by 2 to find a smaller factor. 2 and 96. But 96 is also not a perfect square, so that doesn't help us. If I do 192 divided by 3, I get 64, and that's going to help because 64 is a perfect square. So that means I can think about this as not root 192, but as the square root of 3 times the square root of 64. My calculator tells me that root 64 equals 8. Or maybe I just know that root 64 equals 8, so we write that down to take care of root 64. And then root 3 is not going to simplify. But if you want to double check, you can type in square root 3. Sure enough, that doesn't simplify to be an exact value. So we're going to end with an answer of 8 root 3. And I had a hard time in my last video remembering the units, so I'm going to try to do better with that today. Feet for this one. Okay. Today, if you take a sneak peek at our Pythagorean Theorem problems, you're going to notice that there are now radicals, or radical expressions, for some of our side lengths. And then in some cases, the problem doesn't look too much different than yesterday, but some different kinds of algebra are going to pop up along the way. And so to get ready for that, we need to make sure that we understand how to simplify when we have a root that's going to be squared. Now, square rooting and squaring are inverse operations. So it is true that they just undo each other. So if you know that they're inverse operations, you might just know that this is going to be equal to 15. But if you don't know that, the math that's happening behind the scenes is that anytime we square, that means that we're multiplying that number by itself. So we're multiplying root 15 by root 15. That means that we can combine those roots to be a single root. 15 times 15 is 225. And then because it was 15 times 15, 225 is a perfect square, which then simplifies, which confirms the answer that we already had. Now what's important to recognize is that if you have a coefficient in front of your root, you can't just imagine that root disappearing. You really need to think about multiplying 3 root 5 by itself. And that means that the 3's that are coefficients will multiply to make 9. The roots will multiply to officially be a root 25, but then because it was 5 times 5, that's where the perfect square is going to simplify. And so we end up with 9 times regular 5, or 45. Now, if that feels like a lot, you can also square on your calculator, but you need to do it very carefully. These are both written with parentheses because that's what you have to do in order for your calculator to be able to follow order of operations well. However, when I put a parentheses out front, my calculator puts another parentheses when I open up my root. So to do this problem correctly on my calculator all at once, I would need to close both of those parentheses and then use my squared button. And there it is, 15. Same thing with this second one. If I open up those parentheses, 3 square root 5, I need to close both and then square. Now, if your calculator doesn't open up this parentheses, you would just have 1 at the beginning and 1 at the end. It's really difficult for people to remember to do that though, so another option is that you can type in the root and click enter to see its decimal approximation, and then right away, without clicking clear or doing anything else, we can tell the calculator to square that whole answer, and it will spit out the right answer then as well. Same thing here. So we would type in 3 root 5 and click enter to see it as a decimal approximation, and then tell the calculator to square that whole entire thing, and we would get that same 45. So if you want to use your calculator, my advice is that you type it in to see what the root is close to as a decimal, and then right away square that decimal to get to that answer. What we don't want to do is type in 3 root 5 and see it, and then chop this off and call it 6.7 and square it, because 44.89 is not the right answer. So you have to make sure you do 3 root 5, and then you just click the squared button, and it will pull that whole answer down and square it perfectly for you every time. All right, even though the calculator can be a workaround for these two, you have to remember that squaring means multiplication by itself when it comes to the ones that have addition and subtraction. This is a review from yesterday, so remember we multiply x plus 5 by itself. First up is x times x, which makes x squared, then x times positive 5, and positive 5 times x, and then last positive 5 times positive 5. We've got some like terms here in the middle, so our final official simplified expression here will be x squared plus 10x plus 25. All right, this one is different because we're asked to solve here. And so if we're asked to solve, we're going back to our algebra memory banks. We've got an x squared term and an x term. That means that I'm going to be solving by factoring, which means I need to subtract the 5 over so that the whole equation will be equal to 0. And then because there are no terms that these three things have in common, there's no greatest common factors, I'm going to factor into 2 binomials. And there are all kinds of different methods for factoring. Some of you use the box method, some of you use an X, some of you just kind of do arithmetic and guess and check. Whatever your method of choice, you need to know how to separate this into 2 factors. They're both going to start with X because that's how we get x squared. And no matter what method you think about, you need to think about numbers that multiply to be -5 and add to be -4. So the only numbers that multiply to be -5 are going to be -5 and 1, or +5 and -1. But if I want them to add to make a negative, I need that 5 to be the negative value. And then at that point, we split this into 2 equations that separately are equal to 0. Add 5 to solve this one and get our first answer. Subtract 1 to solve this one and get our second answer. So we have now solved and found 2 answers that make that equation true. Okay, now that we've seen a quick review of the algebra skills that we're going to need to know today, as well as some numerical arithmetic skills, we're going to jump in and take care of Pythagorean Theorem. I've got my right angle, so across from that right angle is going to be my C. That means this equation is going to look like 15 squared equals, I'm going to go with x squared for a squared, and then root 197 for b squared. I always put the sides that look kind of strange, like they have radicals, inside parentheses. That reminds my brain I need to be careful when I am doing the squaring. 15 squared is 225, x squared, and then remember this is something times itself. That root and that square cancel each other out because they're inverse operations, or we can type in root 197 and see it as a decimal and then square it, we're going to end up with 197, whichever method we choose. Next step, it looks like I'm headed towards some subtraction. So 225